So in this video, we're going to have a talk about different types of translators. So in the previous video, we had a little chat about the different levels of languages. We had low-level and high-level languages. We discussed that machine code or binary is a low-level language, as is assembly language, which is shown here, because they are both at a level which is close to or is what a computer understands, e.g. machine code. But also as well, they allow these languages allow you to manipulate bits of the hardware or the RAM or the CPU, which therefore means that they work on that level, the low level of the hardware. The high level languages like Python, for example, which is third generation, or any other programming language you can think of that's got more complex features like if statements and looping and that type of stuff. These are known as high level languages, and although they're much easier to code in, the problem is that they can't communicate with the low level parts of the system, so they can't communicate with the hardware in the same way that low level languages can. And also remember, computers have to run machine code. That's their native language. So obviously Python or any other language like that has to be converted back into low level language. So that's what we're going to talk about today, how that's done. So we're going to look at these things called translators. So on the kind of specification, we're going to have a little chat about this bit here really, which is understand that all programs have to be translated back, and also understand the advantages and disadvantages of low-level language programming compared to us. We've already talked about that in the previous video. But it's all about how they're converted, really, and the differences between them. So let's start off with assembly language. So it's quite straightforward with assembly language, really. Assembly language itself is, we've already talked about, uses mnemonics. Now, although it's very similar to machine code because it's like for like and it's line for line, a computer can still not understand this code. It doesn't understand what these mnemonics do. The mov and the add, it doesn't know those instructions. It only understands zeros and ones. So what you have to do is you have to turn this back from assembly language back into machine code. Now that's not such a big deal, okay? Because it's very like for like, so it's not that quick. But to do it, you need an assembler. So require an assembler, perhaps I can spell, to convert assembly language back into machine code, okay? Now this is it's quite a quick process, as each line of assembly is the same as each line of machine code. So if you've got 20 lines of assembly language, you're only going to get 20 lines of machine code. So it's not like you're making a program bigger or smaller. It's going to be like for like, okay, which is quite nice. But obviously it will be slightly slower than running a program coded machine code, because obviously if it's written in machine code, it's going to run straight away like that. It's just going to run. So but then obviously there's the payoff of making sure it's longer to code in machine code. It's much harder. So the time it takes to write assembly and then convert it in an assembler is by far outweighs writing it in machine code. The benefits are there, but it is obviously a little bit of a slower time. And that's all you need to know for assembly language. You need an assembler to convert it back from assembly language back into machine code. Now let's have a check on high-level languages, okay, like Python. So there's two things you can use here. One of them is called a compiler, and one of them is called an interpreter, okay? And we're going to talk about both of these now and explain to you the differences between the two. So in school, you guys have been using Python idle, like this here, to code your projects, okay? So this should look quite familiar to you. And this is known as an interpreter, okay? And I'll explain why. So I've written a very simple program. It's got two functions in it. The function's called here, called example. That runs this function here. And as you can see, it prints out an example. It prints this function has no errors. And then it then goes to this function here called error, which then jumps up to here. And then it says, I have an error. And then the program will see an error here and it will crash, okay? So if I was to run that, you'll see that that program works pretty well, to be honest. If I just move this, you can see it. So there we go. This function has no errors. If I press enter to go to the next function, there we go. We hit the error once we hit that syntax error. Now, this was done using an interpreter, okay? And the reason why, let me find one note, okay? The reason why that's been an interpreter is because it runs the code line by line, which means that it doesn't run the whole code. It doesn't check all of that code straight away. So what it does, if I just reopen Python again, it doesn't actually look at the whole code and go, right, are there any errors? It starts on the first line, which is here, and then jumps to here and works through every line of code until it finds an error. So it will run most of your code until it finds an error, which is a benefit of an interpreter, okay? So if I make some notes on here, you can see what I mean. So an interpreter runs the program line by line. It does one line at a time, so works through each line, okay, sequentially. The program can run with errors. So will only fail, I'll say, when an error is found within a function. So yeah, you can run your programs. So it's good for testing programs, as you can see how it works, something like that. So it's good for testing your program, basically. You can test it out, see how it's going, find any errors as you go, and also it's fairly quick to run the code and see how it's working so far. So as you all know, okay. Now that works quite well on smaller programs, but on bigger programs it will have a little bit more of a delay, kind of loading it up. So they're kind of the general how an interpreter works and the advantages of it, really. The main advantages are that the program runs with errors, so you can test it, and it's good for testing programs to see how it's working, how it's going so far. The major downsides for interpreter, really, and I'll add some more to this when I've talked about what a compiler is, but one of the main problems is it requires the development platform, so we say, to run. So if I was going to send someone this code here, this Python code, again, wrong one open there, that's the one I want, they would need some kind of Python interpreter like idle or one of the others out there to run this code. This doesn't run outside of Python, okay, which isn't very efficient, really. So you need to make sure that it has that platform to run. If you send that code to me, I couldn't run it without having that language, okay, without having Python idle to run it. So it can't run outside of Python, which is a bit annoying, really, if you wanted to package it up and sell it to the public. The other issue as well is it outputs the source code, okay? So this here is known as the source code. Now the source code is basically how the program was created. So anyone looking at this, I know it's a very simple program, but they can look at this and they can say, right, I know exactly how that program was made. So if this was a program that a company had made and they wanted to sell it to the masses, another company could look at it and go, oh, I see how that was done. I can see the source code. Let's steal that idea, because it's really hard to copyright algorithms and really hard to copyright kind of code itself. So that's one of the major issues. So let's say Microsoft and Apple, for example. If Microsoft released a product that the source code was visible, a company like Apple could see exactly how they've done it and potentially steal it or rework it in a way that they could use it in their own way. So a lot of companies want to keep their source code secret. Also, as well, from a cybersecurity point of view, if you can see the source code, a hacker or a criminal could look at it and go, right, I can find an exploit here. I can see how this code works. I can find a way to exploit that and steal money or break the code, okay? So outputs the source code, which means, so it's not great for distributing the product. So e.g. businesses might steal the idea, or hackers could see the code and exploit. Not really hackers, really, because it's not really needs hacking to see, but anyone with any kind of malicious intent could see that. Come on, spell check. Ah, there we go. So anyone who's got malicious intent can basically see how that was written and go, right, I'm going to exploit this, and that could be damaging, okay? So interpreter is great for testing your code and running it line by line, because it runs with errors. But if you want to actually package it up and sell it to the masses, it's not great, because you need the language to run it. You need Python idle or similar. And then you also need to make sure the source code is available, which isn't great either. Compiler, on the other hand, is it basically checks through all of the code line by line in one go. And then what it then does is it turns it into a packageable product. So if you ever bought a game and you bought it on a disk, or you downloaded it from the internet, you get like a .exe file, and that is the exported version, the compiled version of that program. Okay, so a compiler checks through the whole program and basically packages it into an executable form outside of the development platform. What that means is, okay, at the moment, my Python program here is running in idle, okay, but if I was to compile that program, okay, which you can do in one of these options here, okay, it's there somewhere, okay, you can export it, and then I could run that without needing to run it with idle. I could put it on a disk, I could put it on the internet to download, and someone could run this program without actually, you know, needing Python idle to do it, which is great, because when you buy a game, you don't necessarily need the engine it was made in to run it. You don't need Unreal Engine, or you don't need Unity or whatever it was made in to run it. You just run the game because it's all been exported and compiled that way. Okay. The major issue with this though is compiling only works when the code is error-free. So whereas before I could run my code without needing any errors in it, I could run it with errors, for example. Compiling will error because it checks the whole code before it exports it, so you can't run it until you've absolutely compiled it. So that's one issue. So any errors have to be sorted. So if you've got a program that mostly works but has got a few tweaks that you're doing, you can't compile it. It has to be error-free before it works. Also, one advantage though of compiling as well, another advantage though, is that compiled programs will run quicker than interpreted programs. So remember, when you're running it line by line, it takes a little bit longer, whereas if it's compiled, it'll be much easier to execute. So it'll be much quicker, much more efficient. So it's a good thing to do. There is a bit of time to actually compile it, but once it's compiled, it'll run much quicker, which is also a benefit. And the major benefit to compiling something is it turns the source code, which I said before was like how the program works, into object code. Now, object code is basically a language which the computer can understand what it needs to do, but it doesn't quite show the source code. So it's like almost, the way to think about it, it's almost like an encrypted version of the source code. If you were to look at the object code, you would see kind of how the program was put together, but it isn't literally like, here's clearly how we wrote it. So it can be reverse engineered if you really care enough and have enough knowledge, but actually it's a lot of work. So it's almost a good way to hide your secrets and hide how things were done. It's almost like making it a copyrighted version of what you've done. So you compile it, turns it into object code, and it's out there to the world, and it's all good. The best way to show these two in an analogy, let me show you. Here's video editor. Oh, that's not one. Here's video editor. Okay, so this is obviously a Microsoft product which you can edit videos with. It's very basic. So at the moment, this is the video editor. So here's a project we're working on with Year 9s. And as you can see, I can run this program within video editor, this video, but I can't actually run this outside of video editor. This is like the interpreter. I can edit it, I can change it, I can run it, but I can't give this to anybody without them having a video editor. But if I go to finish video and export that video, it's then the equivalent of being compiled. It saves it as an MP4 that I can then stick on YouTube, or I can distribute to someone via DVD or whatever medium you can think of, and they can run it without it being a video editor. So an interpreter is like the development area where you make the program, and then the compiler is the way you export it and then distribute it to the masses, and it will run on pretty much every machine that it's being compiled for. There we go, guys. So that in a nutshell is how an interpreter and a compiler works. So remember, assembler is only used for turning assembly language, low-level languages back into low-level languages, so it's pretty quick and efficient. Compiler turns the whole thing from source code into object code. It's got to be error-free, but it will run quicker than interpreted, and it can then run outside of its development language, e.g. Python idle. An interpreter runs it line by line. It can run with errors. It will only fail when it finds that error for the most part. It's good for testing your program, good for seeing how you're getting on so far, but it does require the development platform to run it, and also when you distribute it, you will have to give away the source code, which obviously is quite a few grey areas if you've got kind of secrets in there you don't want other people seeing. So there we go, guys. So hopefully that was useful.